So thank you very much for joining us. And today will be mostly a show and tell session to introduce the team and to talk through some of the initiatives that we're embarking upon for 2026. So let me just share my screen and we'll bring up the agenda. Actually, before we do that, before I start sharing a screen and we can see each other's faces easily, let me introduce the team. So I'll start first. I'm Martin Halford. I'm the CTO for Polymath and Polymesh and the interim CEO for Polymath as well. So I'm the guy who gets it in the neck when things go wrong. So now can I just introduce, we'll go around the room. So Francis, you can go first and just nominate someone else to introduce themselves.
Sure. So I'm Francis O'Brien. I'm the head of developer relations at Polymesh Labs. So people will know me on Discord as FOB. Been part of the team since pretty much 22, so coming up to 4 years nearly with the team. So helping people just make sure that they have the technical answers to their question to make integration as smooth as possible. Robert, do you want to go next?
Okay, so I'm Robert, team lead on the core team. So I've been mainly focused on that. You probably see me on Discord or GitHub as NeoPallium. So I don't have a lot to say. Henrique, do you want to go next?
Sure. Yeah. So I'm a software engineer. I'm also part of the core team with Robert, and mainly responsible for adding features to our blockchain. Yeah.
I can go next. I'm Amir Sarinja. I'm the head of blockchain cryptography at Polymesh. And yeah.
Okay, yeah, good next. I'm Lavish, and I'm mainly responsible for implementing Dart. I've been with Polymesh for about a year now.
Yeah, I'll go next. Yeah. So I'm Prashant Bajpayee. I am basically in the middleware team, responsible for adding features in SDK, subquery, and REST APIs, other stuff. So yeah, that's me.
Right. Mehdi, do you want to say who you are?
Yeah, of course. Hello, it's Mehdi. I'm the technical lead in Polymath, and I joined around 2021. I've been mainly developing PCP, which is a for-profit application on top of Polymesh. And here we are. Yeah.
Thank you. And Adrian, do you want to announce yourself too?
Sure. Yeah. Nice to meet everybody. I'm Adrian Huntelaar. I'm the head of client success at Polymath. So I help issuers get on board PCP. I think I'm the only one in the room who doesn't know how to code. So.
Well, Natalie might be pushing you there for that one. So Natalie, do you want to introduce yourself as well?
I used to code when I was an engineer. Yes, hi, I'm Natalie. I'm the group level CFO. And I've been with Polymath for about a year and a half, and excited to kick off these committee meetings.
Fantastic. And last but not least, Daniel, do you want to mention who you are? Yeah, we can't hear you, Daniel. Okay, well, Daniel's sorting out his sound. Daniel is helping us on Discord and moderating the channels. So if you see Seal on Ice, then you'll know who Daniel is. Great. All right. So let me just quickly share my screen, and then we'll get into it. Okay. So the agenda today is we've done the introductions, and so you've got to meet us all. By all means, feel free to reach out to us on Discord if you have any questions. And so we're now going to go through and look at the roadmap for 2026. So this is a roadmap that was put together late last year, and it pretty much dictates what we're working on at the moment. And I think we'll get the Fran and the team to talk through some of the technical details here, but the main gist of this roadmap has been that we're taking much more of a Ethereum-centric view on the world. It's been pretty much, Ethereum is the 400-pound gorilla in the room, and we've had to deal with that. And thankfully, our friends at Polkadot and the maintainers of Substrate have been developing Ethereum compatibility. So we've embraced that at Polymesh, and we're actually in the process of implementing that. There were some implications for us, which we'll get the team to talk through in a minute. And as a result, we had to make some core UX improvements to the platform in order to accommodate that, which we'll talk about in a second. The other main thing for us was the privacy first pivot. So Amir's done some fantastic work with Avish to implement a zero knowledge proof encryption layer onto the platform to allow us to keep assets confidential, and we'll have a demonstration of the confidential assets app in a second as well. So so in summary, we have at the moment we have deployed confidential assets to DevNet. We have release 8.0 coming up in a little while as well. We're making core UX changes, and there'll be EVM compatibility coming very soon, along with contract support for Dart. We'll talk about the roadmap down for later on in a minute. So I think what we'll do now, actually, Fran, I'll ask you if you want to. Actually, let's start with Robert. Do you want to talk about the release 7.x update or release and the 8.0 coming out, and then we'll talk about confidential.
I can give an update there, Martin, if you want. First of all, just on just kind of if you can bring back up the presentation, and we just talk around, because there's some of these features kind of tie in with what we're doing in 7.4 and what we're doing in 8.0. So as this slide kind of suggests, we've been kind of, to an extent, rowing our own boat, or whatever the saying is, paddling our own canoe. That's going away from the Ethereum workflow, while Ethereum has kind of grown bigger and bigger in terms of its adoption. People have latched on to the simplicity of ERC20 tokens, whereas we've been building a regulatory focused first and institutional focused first blockchain for securities. We have run up against numerous roadblocks, particularly during integrations where people are they expect an ERC20 token with minimal restrictions and really simple interfaces. And particularly towards the end of last year, we've encountered, through a number of different integrations, particularly with custodians and wallet providers, them just taking a very Ethereum-centric view of the world and trying to have us fit into that, particularly things like having assets held in portfolios under identities, was a little bit alien to them. So one of the key features of 7.4, which is hopefully going to be released on mainnet next week, is that we have added functionality where keys can now hold assets. So they're effectively another type of portfolio now. So it's basically a way that you can send and receive Polymesh native assets directly to a key and hold balances at a key level. So that's the main update in 7.4. There are some other things that are kind of in preparation for 8.0 changes and a few kind of small tweaks here and there. But that's kind of phase one of us moving towards having a little bit more EVM compatibility. 8.0 is primarily we're kind of several releases behind the upstream Substrate or Polkadot SDK releases. So the intention with 8.0 is to bring us to a much more recent version of Substrate or the Polkadot SDK, which will bring a number of features along with that. It will allow us to do things like having compatibility with the generic Polkadot Ledger app. So they've unified an app that can use it uses metadata hashes for transactions, so that when we do chain upgrades, we don't necessarily need to be updating the app on your Ledger devices every time. And there's a few more hardware wallets that have adopted a similar approach. So it kind of expands the number of apps that are potentially out there that can be used for holding Polymesh assets and submitting transactions. So that bringing us up to newer versions of Substrate also allows us to bring in some of the new benefits and the new features that Polkadot have been introducing. So one of the recent developments on the Polkadot side of things is the implementation of the Revive palette, which is their Ethereum, their EVM solution. So they built a RISC-V VM on top of Substrate, which will run a EVM. So when we have that EVM in Polymesh, it will allow people to deploy standard Ethereum contracts on Polymesh, and that will then allow us, in a subsequent release, to introduce some compatibility layers where we will map Polymesh native asset functionality to smart contract interfaces so that people can use Ethereum style smart contracts for interacting with the underlying Polymesh native assets. And that will hopefully, so it might be a case of we might have like an ERC 3643 style interface for a Polymesh native asset. So it won't necessarily give the full functionality that the Polymesh blockchain has available to everyone, but for basic send, receive, asset transfers, where wallet providers and exchanges and custodians are, it's relatively simple for them to add another EVM compatibility chain into their infrastructure, whereas a full Substrate integration is that bit more complex. So that's what we're kind of looking at. And as well, just in terms of the core UX changes that we're looking at. So we mentioned about keys being able to hold assets. One of the other things is that a friction point that it's there for a reason, but it we get a little bit of pushback and confusion from custodians and people who are used to, if somebody sends me an asset, it just arrives. They don't fully appreciate the anti-airdrop capabilities that receiver affirmations allow. And at our institutional level, that makes sense. So what we are considering, we believe that we'll probably move forward with this, is that the default going forward will be that it's an opt-in for receiver affirmations. So the default will be that for either all assets or particular assets, you will no longer have to affirm receipt of those assets, which will allow assets to be sent in a single transaction rather than having bipartisan affirmation, unless the receiver opts into that. So it's still, we will still have that functionality. So people who do have a concern about that, about airdrops to their accounts, will be able to disable that so they can reject transfers to them. So that helps in a number of ways with us being able to implement kind of one-shot transfers. So in 7.4, the initial implementation will, for the address transfers, will support a single one-shot settlement, assuming the receiver has already pre-approved affirmation of that. So we have that in place today, that you can pre-approve assets. But it's an opt-in to pre-approve rather than opt-in to require approval. So we're going to flip that around in 8.0, so that we will do a migration so that nothing will change for people who are there, but for any new keys, new accounts that are set up, the default will be that you'll require affirmation, or you won't require affirmation to receive assets unless you turn it on. And for old accounts, you'll be able to submit a transaction to disable that as well. So as well, to move towards the EVM compatibility, just on point 3 there on the slide that Martin has up, we're going to implement the classic ERC20 spender approver flow to allow interactions with smart contracts. We have functionality that somewhat emulates that, but not exactly in the same flow. So that's another feature that will come in 8.0. Robert, I know I've given a very high-level summary there. Is there anything that I've missed in particular that you feel is worth highlighting?
No, that was a good overview. Thanks.
Fantastic. Wonderful. Thank you very much, Fran. So I think, so in terms of release 7 and release 8, so what are the ETAs on these being deployed?
So 7.4, we are, I think, Robert, you were planning to get it onto staging today or tomorrow. 7.4 is a non-breaking change, first of all. So we're adding features rather than doing any drastic changes to anything. So that we expect to be on staging this week. We will probably get it onto testnet maybe Thursday as well, and then probably mainnet next week, assuming that there's no issues as we go along. We're working on SDK and subquery updates in parallel, so that when we deploy to testnet and mainnet, we'll have subquery updates available, just to make sure that there's no issues with the new events, to make sure that they're correctly indexed and available. In terms of implementing the features into dApps like the Polymesh portal, we haven't really committed to a timeline on that yet, but the chain will support from 7.4 keys holding balances. But that the portal and other dApp updates will follow.
Awesome.
8.0 is currently, we have, I think, internally at least selected an auditor. I think it needs to go through financial approval within the organization. So assuming that that gets approved, we should be starting our 8.0 formal audit in the coming weeks. So depending on the timeline for completion of that audit, we will be moving to our release cycle for 8.0. The 8.0 release cycle will be longer because there are breaking changes in 8.0. So some of the breaking changes, but there's not a lot of breaking changes, but some of them are relatively significant. That it will require allowing different integration partners a bit of time between when we get it onto staging and testnet and mainnet. So we'll be doing the releases in parallel with the audit, and we will be notifying various partners around them. One particular update which is breaking that needs to be highlighted to exchanges is that we are moving to the standard Polkadot balance palette functionality for PolyX transfers. So those who are familiar with the blockchain today know that we use a transfer and a transfer with memo function, whereas Polkadot uses transfer allow death, transfer keep alive, or I think there's like a transfer all. They have a few transactions. On Polymesh, we don't have an existential deposit configured, or it's set to 0. So keep alive or allow death, we don't reap accounts. That's a design choice that we made when we released the Polymesh blockchain. So we had our own simpler kind of transfer function, and then we had the transfer with memo to allow exchanges to identify unique users and things like that, so they could use a memo field to identify accounts. Last year, if people remember, we moved away from requiring addresses to have a DID to hold PolyX. So by removing that, it's kind of simplified the memo is no longer required for exchanges, assuming an exchange has implemented support for unique deposit addresses for individual users. So because we have that little bit more flexibility and we can move to the more standard transactions without a memo, we feel like that it's appropriate to realign ourselves with the Polkadot transactions, which simplifies future wallet integrations and exchange integrations. So I've lost my train of thought there, but anyway, we're working on, so we will still have a transfer with memo functionality, to maintain compatibility with that. But because we'll be moving to standard Polkadot events, the events that we currently have include a DID, which was optional in that. So kind of if we have different fields in our events, say 1 is the DID and 2 is the amount and 3 is the address that it's going to. And I don't know if that's exactly it, but we will be removing that DID, so it'll be a breaking change in the event structure. So for exchanges to be able to detect deposits, they'll need to be basically indexing the correct, the newer event, which is essentially the same event that they will be doing for Polkadot. So it should be relatively straightforward, but we need to just make sure that exchanges have enough time to prepare in advance for that change. So it's relatively simple, but it is a breaking change, which would not result in any loss of funds, but it may delay exchanges reflecting balance updates for deposits. So because of that, there are some other breaking changes, and we are doing improvements around settlement, but that's the one I'm probably most concerned about in terms of getting that notice period out to exchanges so that they can prepare for that.
Awesome, fantastic. Thank you, Fran. Okay, so a lot happening there. The other thing that we've been very proud of recently is something we call confidential assets. And we're very privileged to have Amir working with us, who is a PhD in cryptography from Edinburgh University. He worked on confidential assets along with Lavesh. So Amir, do you want to give us a bit of an overview as to what are confidential assets and the background behind this new feature?
Sure, of course. Thank you very much, Martin. So before starting talking about the details of DART, DART stands for Decentralized, Anonymous, and Regulation-Friendly Tokenization. As all of us know, basically leading global institutions are actively investing in tokenization. So far, they have invested more than, if I'm not wrong, $400 billion. But the important question is that why over $30 trillion basically potential for real-world asset tokenization still is off-chain. And I personally believe that one of the important drawbacks is privacy. So blockchains have this privacy issue. While there exist some privacy solutions out there, including, for example, Zcash or, for example, Monero, Aztec, and so on and so forth, they have basically compliance issue, meaning that they don't have any built-in compliance feature. But on the other side, we've got some protocols that are basically compliance friendly, including ERC 3643 or Securitize and so on and so forth. But these basically platforms and protocols, they lack built-in privacy, which means that we are basically missing one unified protocol that has both privacy and compliance at the same time, which is exactly what we deliver via DART. Which, as I said, which stands for Decentralized, Anonymous, and Regulation-Friendly Tokenization, which tries to basically introduce a new cryptographic protocol to show that we could achieve both privacy and regulation, which are in direct conflict with each other at the same time. So just in one sentence, if I have to summarize it, privacy says, let's hide information. On the other side, regulation and compliance requires information to make sure that, for example, sender is not laundering money or receiver is not terrorist, so that we are not financing terrorism and these kinds of stuff. Which this simple example shows that privacy and regulation are in direct conflict with each other. And being able to achieve them in a decentralized setting where you don't want to trust a single centralized entity for taking care of everything makes it even more challenging to achieve these two conflicting requirements at the same time. And that's exactly what we have been shipping and basically developing via our protocol called DART, which shows that how to actually achieve these two conflicting requirements at the same time. Of course, there are so many nuances and details here. What we mean by privacy has so many basically sub-notions within it. Privacy means hiding who is the sender. Privacy means hiding who is the receiver, hiding what is the asset type that is being sent from sender to receiver, hiding basically the value of transaction, balances of users, basically hiding everything. On the other side, compliance has so many basically details as well. A few of them was mentioned by Martin, including, for example, receiver affirmation, which simply says that I, as a receiver, because of tax implications, I should have this responsibility or discretion to decide whether or not I want to receive something, just or not. Like for example, a canonical Ethereum transaction doesn't have that feature, right? If a sender has a, let's say, a stolen money, they can freely send it to any receiver, right? There's no requirement saying that receiver should explicitly affirm such a transaction to be able to actually receive it or not. However, we have it here because, well, we are targeting, we would like to capture, as I said, responsibilities associated to having a transaction, to be able to capture basically real-world asset tokenization for those types of assets that are heavily regulated. Of course, I'm more than happy to provide more details because, as I said, there are so many basic nuances and details around it. But I guess I hope that I could communicate at least basically in high level what this DART actually is trying to do.
Fantastic. Thank you, Amir. And for those who are interested, there is actually a quite comprehensive white paper that Amir has written along with Lavesh, and which explains this in detail. So if you want to get into the cryptography and the maths, you're welcome to. Right now, I think, Fran, you might have a demo that you can show off the confidential assets in use. I'll hand over control of the oops. Okay, looks like I can't. If I stop sharing, are you able to take control, Fran?
I don't, just if you
just see if I can. Have you got it? Great, fantastic.
Yeah. So for people who want to get into the real technical detail, Amir's paper is definitely where to go. If you want to get a little bit more high level and try and understand some of the core functionality, we've got some good documentation at developers.polymesh.network/confidential assets. So where we kind of cover what are confidential assets. So we've tried in the documentation, we've referred to them as confidential assets, but DART assets or PDART assets are effectively the same thing. It's our implementation. Our confidential assets is the implementation of PDART, which is an extension of the DART paper, that both of which Amir has written. So there's direct links to the different research papers and white papers available here as well. So there's some good reading here, or feed it into an LLM and have it kind of spit back a high-level summary for you if you want to kind of get the synopsis of what's involved. So we talk about the architecture, onboarding of accounts, what's happening, why we're doing it, different operation of assets, settlement workflows, compliance and regulation, how it works in. We've got nice features that I'm not going to show today that are available on chain, but they're not implemented in the UI that we have around trying to have anonymous transaction fee payments. So that's obviously one of the concerns, is you're still going to have to submit blockchain transactions. Somebody's going to have to pay the fees. So we have thought about these kind of things so that you can separate who's paying the fees versus who's submitting the transactions, using kind of relayers or different third-party service providers. So I'll leave those documents there for if people want to look at them. There's some nice workflow diagrams that kind of explain the settlement process. Also, if you're interested, I think, go away, why can't I? if you look on the GitHub repo for the confidential assets UI, if you're getting into a bit more of the detail, we have some, again, sequence diagram, workflow diagrams available there that you can review to understand a little bit more about what's actually happening behind the scenes. The UI that I'm going to demonstrate, I think, I personally think it does a good job of hiding a lot of the complexity, which is good in a way, but it doesn't really show the breadth of work that Robert and Amir and Labesh have been doing in Enrique in implementing the functionality that we have developed. And this is cutting edge stuff that we're working on, and we're still iterating on that and improving it with a view to bringing it to mainnet in the not too distant future. So this DevNet UI is available to anyone who wants to use it. So you can go to devnet-confidential.polymesh.dev, and you can walk through this demo. There are some guides available to tell you the different steps and why you're doing them if you get stuck. So I've already created some keys in my Polymesh wallet for issuers, investors, etc. And I'll go through the process anyway of creating an asset and doing a confidential asset settlement so that you can kind of see what's involved, and I'll try and explain why we're doing things as we go along. So I've created an issuer, I've created a mediator, an auditor. I'll possibly just keep it as simple as today. What I'm missing currently is an investor. So I'm just going to switch to investor one, and the first thing I'm going to do for testnet for this DevNet is just onboard it. So for this DevNet, it's just a simple click this button. What's happening behind the scenes is it's creating a DID for that account, and it's going to transfer some PolyX to that address so that you have some tokens to allow you to transact on chain. So that's linking your signing key from your wallet to your DID, which is your on-chain identity to represent that investor. That should just take a couple of seconds to complete. So the next thing I want to do for that investor, I want to create, I'm going to generate new keys. So these are going to be confidential. This is essentially the confidential account. I'll assign it a password. And I'm going to generate keys. So what this does is it creates two keys. It creates what we call a confidential account key and an encryption key. And these two different keys are what make up your confidential account. Your asset balances are going to be held at your account key, and the encryption key is used so that you're able to decrypt the information related to settlements. So that when a settlement instruction is created, you have your sender, your receiver, your asset, your amount, all that detail is encrypted using encryption keys for the parties that are involved in that instruction, so that everyone who's involved in it can decrypt so they can see what the legs that apply to them. So only the legs are encrypted with that, so they can only see the legs that they are a party to. So if you have a transaction which involves multiple assets and multiple parties, you can only see the assets and the amounts that you are involved in, not the ones that third parties are involved in. Or if you're an auditor, the instruction will be encrypted with your encryption key so that you can decrypt that as an auditor or mediator likewise. So once that account is created, it needs to be registered on chain. So this basically links the confidential account key and encryption key to that DID on chain. So this just submits a transaction, which I need to sign in my wallet, which is just popping up over here. That is being submitted. So that's the first step of registering your confidential account on chain, just to link that to your DID. So now that we have that created, I'm going to go back to the issuer and just create an asset. That should be successful. So I'm switching to the issuer, and I'm going to switch to the issuer's confidential account as well. So on the asset tab of this UI, we have a button for create an asset. There's a little wizard that walks you through creating an asset. The details that you require are relatively minimal, but we have the assets do support a metadata field, which we can populate with key value pairs in a JSON format, or any information. If you want to go to, it had some kind of encoded or encrypted data, you could do that in another format. But this UI, we're just using a JSON format. So I'm just going to create a stable coin in this case. I'll name it ESC demo and call it TSC 2026. We're going to set 6 decimals. The number of decimals we limit it to 8. It does matter to an extent, because when it comes to decrypting legs, if you don't know what the amount should be, you're basically having to kind of iterate through that. So we limit it to 8 decimals at the moment, just to make sure that it doesn't take an excessive amount of time to iterate through millions of numbers. So in these fields then are just basic key value pairs. You can put in whatever you want, or you can add custom fields if you wanted to have some bespoke metadata associated with your asset. The next step in the wizard is to assign an auditor or a mediator, or both. I'm going to just assign demo auditor here from one of the keys that I've selected, or you could paste in the account that you want to add in if you have the encryption key for the auditor that you want to use. I'm not going to add a mediator here just to simplify for this demo, but the mediator, if involved, is a third party that has to also affirm the instruction before it can execute. So that's an important role if you wanted them to be considered like a transfer agent, where they are enforcing compliance. So with non-confidential assets, you can do a lot of compliance enforcement on the blockchain. We don't have that available yet for confidential assets, so we rely on a third party like a mediator to enforce that that compliance, similar to how a transfer agent would do it for traditional securities. Once we have that finished, we can just review the information and submit the transaction. This again will submit a blockchain transaction to create that asset. So that just again takes a couple of seconds for it to finalize. Encryption key missing for a confidential account.
The auditor may not have been registered.
Oh, it's not registered yet. I'll just use the mediator as. I think I registered the mediator. I'll just use the mediator as the auditor. It's just that confidential account. Let's hope this works this time. Okay. So after this is created, the next step for us is to issue some tokens. So I've created this asset, which is our TSC demo. The first thing I need to do before I can create it is I need to register that asset. So by registering this, what I'm doing is initializing an account state for this asset for me. So this basically, your account balance is going to be 0 at the start, but we need to tell the blockchain what encrypted 0 looks like. So we actually have to register it on chain to put an entry into the curve tree for the balance of this asset. So it'll be encrypted as a balance of 0 for this confidential account. And each user that wants to hold that asset is going to have to register to initialize their account state for that asset. In this demo, we store locally that account state in the browser. So if you were to clear your browser cache, you will lose that account state and it will kind of make things not functional. It is possible to recover that, but we just haven't got the functionality here. So if anyone's testing and they happen to clear their cache, just be aware that your account state will be erased, just for your information. Once it's registered, we're able to mint tokens. So let's say we want to mint 10,000 tokens. At this point now, because we're increasing the balance, there's a zero knowledge proof actually being created. So for this demo app, everything is happening in browser. So the proof generation is being done by a WASM library that uses the cryptography that Labesh and the guys have been implementing to create that zero knowledge proof. And then when that proof is generated, it's submitted to the chain. So I keep typing in the wrong password here. Submitting that transaction. So when that proof is submitted to the chain, it'll be verified by the chain to make sure that it's valid, and the curve tree entry will be updated to reflect the new balance of the confidential account. And just for information, I'll just click on the view and explore so you can kind of get an idea of what information is actually being shown. So I'll go to here. So you can see a different events, account leaf state inserted. There's nothing there. There's nothing in any of these that are going to tell you what the balance updates and what asset was involved. So from an external user looking at the blockchain, they won't really know what sort of transactions you're submitting. But auditors and people like that will still be able to tell what your balance is. Now, the total asset balance is public. So the fact that I've minted the asset and then I've created the asset and then I've minted 10,000, that is going to be available to everyone. So anyone who registers for that asset will be able to see the details of that. So just clicking on the asset details, this is all public information for that asset. So the asset ID, total supply, metadata that's been submitted by the user is all public data, who the owner is, who the auditor is. So now that I have some tokens, next thing I want to do is be able to send them to somebody. So before I do that, I'm going to switch to the investor account. I'm going to switch to the investor's confidential account. So he doesn't have any assets. Asset ID 9 was what so we're just going to, you can look at the details again. You can see the same details available to the investor. We're going to register for this, which again will initialize the account. Initialize account state so that the encrypted balance is set to 0. And Amir and Robert, always feel free to step in and correct me if I'm saying anything that is not entirely correct, because my terminology may not be exactly for the research papers and that, but at a high level.
That's good. But one thing I'd note is that the issuer could set up the transfer before the investor actually registers the account, because the chain, when the transfer is set up, the chain doesn't even know the sender and the receiver, so the chain can't verify if those accounts have been registered. But the investor will have to go through the registration step before they can accept it.
Yeah, and the UI actually allows that. So I could have created it once I had the investor's confidential account. I could have created it, but when it would have come to the step where the investor goes to affirm that instruction, it would basically say, you're not registered for this and you need to go off and register it. So I'm going to create a transfer. So we're going to send, I need to switch back to the issuer who has the balance. Interestingly, or maybe not necessarily interestingly, but once I have the confidential account selected here, for something like a transfer, I could actually have a different signing key selected that would actually pay the fee. So if you kind of think about it, one key generates the zero knowledge proofs, passes them on to another one, and that key can submit them. So it's kind of, you could use that as a way to anonymize where who was submitting a transaction, by sharing that zero knowledge proof to another key, or spinning up a new key, transferring some Polymesh to it from an exchange or something. So it kind of goes through a mixer where it's not obvious. So you can mask the non-confidential aspects of the Polymesh or PolyX transaction fees using additional accounts, or you can use the fee payer mechanism that we've also developed. So if I was to have left that as the investor, it would still allow me to do it. It's only specific transactions like minting new tokens or creating assets where you need to have the DID that is the asset owner as the one that's submitting the transaction. So that's just something that is of interest for people who are concerned about that level of privacy around transaction fee payment as a way of leaking that privacy.
And registration too, because the accounts are linked to the user's identity, so those ones need to have the same key. But yeah, everything else related to transfers can be used some type of fee payment.
Okay, so I'm going to send 1,000 tokens to. I need to. That's why I had a second one open, because I need to be able to copy the confidential account for the investor. I'll take their account. We give them the public key. It automatically populates the encryption key because it's read that from the chain because the two of them are linked. Send 1,000, and you can put in any memo.
The memo was public though, so it
Yes.
doesn't get encrypted.
And there was a little warning as well, just associated that is public. So if you did want something sent in that you'd have to, if it was non-public, you would have to be encrypted in some way. Again, just submitting the transaction. So you would have seen some zero knowledge proofs, and actually there's no zero knowledge proof in the transaction construction, but it does do the encryption per the keys that have the encryption keys that are associated with the accounts. So the auditor, mediator, sender, receiver keys are used for encryption of that. So once that instruction is created, we have. Where's it gone? The instruction ID, so we can see it in the Explorer again. So settlement is created. There is a settlement reference number, which is what you would share with people. So you can either be scanning the blockchain, processing every transaction to see, is this one that you're involved in, but that means you're going to have to decrypt it. Or if somebody creates an instruction that you're involved in, if they share the instruction, the settlement ID with you, so the transfer ID, so that's the same number that would have copied from the event. So if I was to share that with the sender, he'll be able to say, okay, let's decrypt this one and see what happens. So my transfers, if I go here, I can see the details because I've loaded in my settlement ID for the receiver. They can paste it in here and decrypt and view, which will bring up, so because it's using your password, to decrypt the leg so we can see the details. So I'm the sender, sending and receiving are both pending affirmation. It's 1,000 tokens. Sender, receiver, again, we can see the full information, etc. And I can affirm as a sender. So that will generate the zero knowledge proof. It just takes a couple of seconds. Once the proof has been generated, a blockchain transaction will be created so that it can be submitted and recorded on the chain. So in this UI, the way it currently is, we've everything pretty much step by step by step. There are some efficiency improvements that you could do where you're batching some of these transactions behind the scenes. And there are capabilities if you have multiple parties that do a lot of this agreement off-chain that generate all the proofs that they can be submitted in a single transaction to kind of batch them all together to do that is a more efficient way. So you still get the confidentiality of it, but you can do a lot of the orchestration off-chain before submitting everything on-chain with all the zero knowledge proofs to do all that. So again, I'll copy the transfer ID and I'm just going to switch over to the investor. The investor, I know this is all in the one UI, so it may not be as obvious, but if you treat these like two completely separate accounts that don't necessarily have any knowledge of each other, so I just passed on this instruction, this transfer ID, and I try and decrypt that. So now as a receiver, I can see that I am the receiver. So this is the instruction ID, one pending affirmation and one pending finalization. So I'll just affirm this, and I'll show you the auditor as well, just that they, as an independent person, can view the instruction and decrypt the leg. And again, just in the Explorer, you can see confidential status has been updated to executed. The account leaf state has been updated as well, which includes the encrypted balance for the account, and receiver affirmation. So there's enough events emitted to let you know something has been happening related to that instruction, but you don't really know the details of that instruction.
And for that one, you actually use the issuer to submit the proof for the investor. So basically that is allowed. Yeah, that's how it's allowed because the chain doesn't know the party. So as long as somebody is paying the transaction fee, the chain is fine. And that's why we have the private fee payment. So you can use a third-party service to submit it on your behalf with the private fee payment, you're reimbursing them for doing that on your behalf.
Yeah. So I've switched to the mediator's confidential account. There's nothing showing in their transfers, but if I decrypt that, it will. So it again shows me receiver, sender, affirmed. I can see their confidential account information, but there's no action for me. I just have view-only access to this. So I know that it's been affirmed by both. It's just pending finalization. And if I look at the transfers, it shows me the information that's available to me. This is a combination of information that has been stored locally versus got retrieved off the blockchain. So obviously, when we're talking about the account states and things like that are stored locally, not everything that is being shown here is readily accessible from the blockchain. Well, actually, pretty much what is here is the kind of the stuff that's from the blockchain. But as you kind of go into the actual affirmation, and decrypting the legs, that's only viewable if you have the encryption key. So the final step, if I would just go back to the issuer, I can view details of this. Again, it will. And if I wasn't switching around between accounts, this would stay unlocked. But just when you're going back and forth, if you change account, it just locks the previous one. In case you're wondering why I have to keep entering those passwords. So after it's been affirmed, there's a final step to update the transaction counter for the sender. So we use this counter, and it's part of the mechanism for how it's documented better in these.
It's for proof of balance, because there's times where you'll need to prove. This is one of the big difference between Dart and like a privacy UTXO is with privacy UTXO, somebody could easily not point to some UTXO or unspent coins and say, oh, those ones aren't. They can just not point to some of the coins that they own, and nobody would know. So with Dart, we introduced the counters so that, and there's not, you don't have multiple live coins. You only have a single live balance, and the counter is in order to keep track of settlements that you're a party on, so you can give an accurate proof of balance.
Yeah, so it's not a mandatory requirement to update your counter after you sent, but it makes it cheaper for future proof of balances, because if there's a counter there, you're going to have to account for all the transactions that are pending that are associated with that when you're going to prove your balance to somebody else. So it's cleaner if you, after a transaction has been executed, that you update your counter as the sender. As the receiver, when the transaction is executed, you need to claim those assets to update your balance, and as part of that, where you then have full access to those, your counter is decremented as well, so that it correctly reflects that you no longer have an incoming amount left to claim.
And just quickly adding to what Francis and Robert were explaining, it is a well-known issue in the literature of cryptography papers and also like blockchain-based payment protocols where this full privacy preserving, meaning that hiding the identity of sender and identity of receiver, which is known as anonymity, is only achievable in the UTXO-based model, not account-based. As for example, Zcash has shown full anonymity is possible, but that's a UTXO-based. And one of the issues with UTXO-based basically systems is that achieving proof of balance, enabling users to prove that how much they have, is not trivial at all. It's in some cases it's even impossible. So what we have shown in Dart is that we are in a hybrid setting where for requirements such as proof of balance, we actually enable users to basically generate an account that has all the funds and monies that they have in the system aggregated in one unified single location, where it is basically their account, such that they can prove things about their balance. But before Dart, as far as I know, there was no scheme out there that could basically offer at the same time full anonymity, hiding the identity of the sender and receiver, and at the same time enable users to provide efficient proofs of balance in a decentralized setting without trusting any entity to come and say that I have access to some decryption key, I can decrypt the stuff and know the balance of users and submit that as a proof of balance. We don't have such a thing. We allow users to basically prove their balance without necessarily trusting any entity. Yeah, thank you.
Yeah,
Awesome.
so I think that kind of concludes the demo. Anyone who was looking at the screen that was being shared would have seen that the balance for the receiver had been updated. All the counters had all been zeroed essentially. So that kind of concluded the full workflow of a single asset transfer using the PDART confidential asset protocol. Obviously a lot happening behind the scenes in terms of all the cryptography and all that's happening, but from a user-facing interface, I know there's a lot of steps here. Some of them can be kind of combined together to simplify it, that user journey, and you can do things like batching. But it's still, compared to a lot of other confidential protocols, is quite a smooth process for what it gives you in terms of full confidential asset functionality of sender, receiver, asset, and balance. So full privacy.
Awesome. Fantastic. Thank you very much, Francis, and for doing that. I think you can probably appreciate this is a fantastic asset we have as part of Polymesh, right? And it's something that we're going to be leveraging a great deal of over the next few months or so to really push this forward. So if anyone's got any questions about this, I'm just conscious of time. So any questions, then please feel free to ping us on Discord. I'll publish a link to this video so people can rewatch it in all its glory later on as well. And feel free to share. But I'll close the meeting now. But thank you very much, everyone, for attending, and we'll chat soon.
Yeah, and just to kind of share with people again, thank you for attending, and for those who are watching it after the fact, again, thank you for watching. This has been kind of obviously the first technical steering committee public call. So it's been more of a show and tell, just to update people about what has been going on, what is in the technical roadmap, what have we been doing, and kind of get you kind of more up to speed. Stuff that has been shared publicly previously, a lot of it, but people may not have gone into the details. So it's nice to have it being kind of demonstrated in a video for people to kind of access that. And look, we're happy to take any questions that you have via Discord, or reach out to me. You can DM me personally if you want to kind of ask something that is a little bit more private. Happy to answer any questions around the protocol.
Fantastic. Awesome. Well, thank you very much, everyone, for attending, and we'll chat soon. Thank you. Bye-bye.
Thank you.
Bye, everyone.